In this video, we're going to take a look at formulas that are associated with probability distributions. So the first formula that we have is the mean for a probability distribution. The way we calculate the mean is we're going to take each of the x values, we're going to multiply them by the associated probability, and then add all of those things up. This value, we also call it the expected value. So we can say when you roll a die, we expect the mean on average to be something like 3.5. So that's the expected value. To calculate the variance, we use one of these two formulas. So the first formula is maybe better for understanding. It feels a little bit more like that process we talked about before for individual data values. But we take x minus the mean squared times the associated probability and add all of that up. However, and when we actually go through and calculate these, it makes sense to square the x values and multiply it by the probability and add it up, and then subtract the square of the mean. That's a maybe simpler process for calculating. We will see that here in an example in a minute. And then we have the standard deviation. That is simply the square root of the variance, and we can use either one of those formulas. So here I've shown this formula. Right, so let's find the mean, variance, standard deviation, and expected value for this probability distribution that is shown right here. So I've put a space down here for some scratch work, so we're going to do the scratch work there. In this first column, I'm just going to take x times p of x. So I'm taking the value 0 times 0.6, and that gives me 0. Taking 1 times 0.2, that gives me 0.2. Taking 2 times 0.1 also gives me 0.2, and 3 times 0.1 gives me 0.3. Down here at the bottom, I'm going to just add up all of those values, and so when we add up that column, I get 0.7. And so that's what's happening in that first column. Notice if I add up the p of x column, that p of x column, that adds up to 1.0, which works. That's nice because that does suggest that this at least has a possibility of being a probability distribution. I also observe that all of those are between 0 and 1, and so it is in fact a probability distribution. In the next column over, so we have our x times p of x column. The next column over, I'm going to have an x squared column. So I'm going to take each of the individual x values, and I'm going to square them. So 0 squared is 0. 1 squared is still 1. 2 squared is 4. And 3 squared is 9. I'm not going to add up this column. I won't need that information anywhere. So I'm going to just leave that. And then in this final column, I'm going to take x squared times p of x. And so in that column, I'm taking this value, the x squared value, times the p of x value, so 0 times 0.6, still 0. I'm going to take the 1 times 0.2, which is still 0.2. We have this value of 4 right here, times the 0.1, which is 0.4. We have this 9 right here, times this 0.1, which is 0.9. So we add that column up, When we add it up, we get, I suppose, 1.5. So now we want to take these values and use them to calculate our mean, variance, standard deviation, and expected value. So the mean, that value is the sum of x times p of x. So that is this 0, that is going to be the x times p of x value will be the 0.7 down here. The variance is going to be 1.5 times the 0.7 squared. The standard deviation is the square root of that, and the expected value is the same as our previous value. And so that's what we have for our values there. All right, we will talk to you next time.